Hello, this is Nairajan working as an assistant professor in the Department of Electrical and Electronics Engineering in MEM School of Engineering, Trichy, aggregated by NAC, approved by IIT New Delhi, affiliated to Anna University, Chennai. Today we are going to discuss about the Unit 5 of Basis of Biomedical Instrumentation, and let us go and view the content of this Unit 5. Yes. So in Unit 5, we can see the biochemical measurement. Okay. Unit 5, biochemical measurement. So what are the chemicals that are consist in our body? Okay. How these chemicals can be measured? Okay, very important point. And so first we are going to discuss about the colorimeter. Okay. First we are going to discuss about the colorimeter. Next, sodium potassium analyzer. Next, spectrophotometer. Next, blood cell counters and auto analyzer, and finally blood gas analyzer. Okay, blood gas analyzer, both in invasion and non-invasion methods. Okay. So first we are going to discuss about this colorimeter. Okay, fine. See, frequently I used to say that the answer for the question will be given as hint in the question itself. Okay, so again, here is a question. What is this colorimeter? Okay, colorimeter. So color. Okay, colorimeter. The color is hidden in that. So in order to find the color, okay, output from the sample is called as colorimeter. The color output from the sample is called as colorimeter. So how this color sample? So the color, okay, color is the different colors we all know very well, that are WebGR, violet, yellow, green, red, blue, everything. Okay, so all the colors are hidden in the white color. Okay, when the equal combinations of all the colors are added, then the resultant will be white or light blue color. That is why our sky is looking light blue. That is one of the reason that our water is also reflecting the same, and it is also observing the same from the sky. Okay, and this colorimeter, okay, it is an optical electric device. Okay, optical electronic device that measures the color concentration of a substance in a solution. Okay, that measures the color concentration of the substance in a solution. Okay, so color, when the color we are discussing about the color, then obviously, okay, so as I said earlier, this colorimeter is operating based on the color, and obviously when we are discussing about the color, the characteristics of the color is the absorption and transmittance. Okay, absorption and transmittance. So the absorption is when there is a very high contrast in colors, then we can see the absorptions. When the colors are similar, then we can see the transmittance. Similar in the sense, if the concentration is very low, then we can find the transmittance, and if the concentration is very high, then we can see the absorptions. Okay, okay, what is the principle behind this? The light of a specific wavelength or color, when passed through a solution, okay, of a substance of certain concentration, of a substance of certain concentration is, it can be the biological component. Since we are discussing about the biomedical instrumentation, the solution of biological component. Okay, so it can be some, so we can take a sample, blood samples also. Okay, so in that blood samples we can measure different components, WBC, RBC, and platelets. But here we will be taking into account only the color. Okay, so the certain concentration is observed by the amount proportional to the uh, length of the passage in the sense the size of the container or cuvette, the size of the container or cuvette where the sample solution and measuring solution is placed. Okay, and here the solutions, the solution and the concentration of the subject. Okay, substance, the solution, the concentration of the subject. So next we are going to discuss about the operating one. Okay, so here see there is some light. Okay, and filter is there and lens, and there are two cuvettes. The two cuvettes, okay, cuvettes, each of same size, One is the containing the solution containing the concentrated, and another one is the is of the same, is placed at a distance. Okay. Next, when light rays is passed in a particular wavelength, it passes through the filter F. Okay, and the light from the lens, okay, light from the lens is I naught, is initially indents on this cuvette. Okay, and again the light I1 is transmitted. Okay, it can be, which is leaving away from the cuvette. Again it is entering into the another cuvette. Okay, and actually I0 will be the greater one and I1 will be lesser, and again this I1 is allowed to pass in the cuvette, and finally I2 is left outside. That I2 is with lesser wavelength. Okay, I0 is more wavelength, I1 is the less wavelength, and I2 is the another less wavelength. So the transmittance can be calculated in the formula T equal to I1 divided by I0 into 100. So I wish to show a small video related to this colorimeter so that you can able to understand, because whatever we are speaking, it is very tough to get into your brain, but if you see a video related to that, you can able to understand clearly.
On the red, blue, and green components of light absorbed by the object or sample, much as the human eye does. For an example, consider the bananas. When white light hits the bananas, all the colors are absorbed except for yellow. The yellow light reflects back and hits our eyes, so we perceive the banana to be yellow. The yellow light that the bananas reflected was really a combination of red light and green light. Now, let's see the basic components associated with a colorimeter. A light source, often an ordinary low-voltage filament lamp, an adjustable aperture, a set of colored filters, a cuvette to hold the working solution, a detector to measure the transmitted light. Let us see how a colorimeter works. The working starts when the light source produces white light, which is made up of green, red, and blue light. The white light passes through a lens, which focuses the light so that it moves in one direction. Then the light moves toward a colored filter. When the white light hits the colored filter, some of the light is reflected, while the light colors which would be absorbed by the sample are transmitted through the filter. When the filtered light hits the sample, some of the light is absorbed. Darker samples will absorb more of the light, while paler samples will absorb less of the light. The detector measures the amount of light which is transmitted through the.
So now you might have understood how this colorimeter is arranged and how it is measured and the output is measured. Okay. Hope you understand. Next we will look after the flame photometer in the next class. Thank you.